Hey, what's going on? I'm Will Button from DevOps for Developers, and in this video, we're going to talk about Big O notation.
Things go well, I might be showing her my O face. Oh, oh, oh. You know what I'm talking about. Oh. Yeah, right.
No, man. I believe you'd get your ass kicked for that. Look, Big O notation is used in software engineering to understand the complexity of how the code being written is going to solve the problem in terms of like the computational resources it's going to use and the space it's going to consume and the time it's going to take to solve that problem. Look, check this out. So you might be wondering why we actually care in DevOps about that. And it comes up in a couple of different formats. So a lot of times we get pulled into problems where someone from the software engineering team will say, hey, we need more memory for this particular application. And so you kind of have to evaluate whether or not that's the right answer to the problem, okay? And so there's not a straightforward answer to this. You've got to understand, like, what's the current capacity or the current resource utilization based on the amount of traffic that we're seeing or the amount of work that that particular service is doing. Okay, let me explain that. There are times where it's just most effective to throw more resources at it. For example, if you've got a service or an application that's running on a pretty small set of resources, like it's only got 2 or 4 gig of RAM and maybe 1 core that it's using, and it starts to get performance bottlenecks, then yeah, throw some more resources at it because that's really not a lot to operate with though. On the other hand, if you've got something that's using like 16 or 32 gigs of RAM, then maybe there's some different things that we can do. The first thing that I look at is what's the throughput or the amount of work that this thing's doing. So if it's using that much memory, but the number of requests it's serving is actually pretty low, this is when I'm going to get into looking for something that's a performance bottleneck that can be improved rather than throwing resources at this. And I do this specifically because this is going to affect your long-term scalability for this application, right? If the answer is to throw more resources at it, you may very well be putting yourself onto a path where it costs more to run this application than you're generating in revenue from your customers. So that's where you've got to turn this around and make it more efficient, which is what leads us to Big O notation. So if we take a look at this function on the screen here, it's just a Python function that adds up 2 numbers and returns the results. So no matter how big of numbers I give to this method or this function, it's just going to add them up and return it. So what we can say here is that this function is going to perform the same regardless of the inputs that I provide. If I give it 2 plus 3, it's the same amount of work as if I give it 2 billion plus 8 billion. It just adds them up and returns the result. So in terms of Big O notation, this would be what's called constant. So it's always going to produce the constant amount of work regardless of the input. Okay, so the next one we'll talk about is a linear algorithm. So if we look at this function here, print stuff, it accepts a list of items and then it loops through that list, printing out each item in the list. So the amount of time that this function takes to complete is going to be directly related to the number of items in the list we give it, right? So in the example here, I've got a list of 5 items, but if I give it a list of 5 million items, it's going to increase, accordingly in a linear fashion related to the list. And we call that a linear algorithm, and it's often expressed as O parentheses N. So the next one on the screen here is what's called a quadratic algorithm. Easy for me to say, right? So what we're doing here is we've got a list of items being provided to the function, and then we iterate through that. But then for every item in that, we iterate through that list again. So the amount of time it takes to perform this is going to scale exponentially, right? Because for everything in the list, we're iterating through everything in the list a second time. And this is called a quadratic algorithm, and it's expressed commonly as O parentheses n to the power of 2 because it is exponentially increasing in terms of complexity. One more I want to show you before I get into why this all really matters. And this one is what's called a logarithmic algorithm. And example I've got here is a binary search. And if you look through this, you give it a list of things to search for, or a list of things, and it's looking for a specific item in that list. And the way it does this is it finds the middle of that list and then looks to the left, looks to the right to see which area might have that item that it's looking for. And then it breaks that, it goes either left or right, then it breaks that in half, looks left or right, breaks it in half again. So it keeps breaking the list in half until it finds the thing that it's looking for. And so whenever this scales with a larger list, the complexity and the time and space that it takes grows logarithmically versus exponentially or linear, and some of the other examples that we've seen. Okay, so now back to the original question posed at the beginning of this video. Why do you care as DevOps? And the reason this is going to come up, like I mentioned, is your software engineering team is going to ask you for more resources for their application, and it's up to you to determine whether adding more resources or starting to do some performance testing and improvements is the right answer to that question. So once you get to the point where adding more memory or more CPU is going to start significantly increasing the cost to run your application, it's probably time to start doing some performance testing, and you're going to have to help your software engineers out with this. So you'll do the performance testing using something like JMeter or Locus.io or Gatlin.io, and then you'll find a section of the code where the performance there is the one thing that's taking up a significant portion of the resources for your application. So then you're going to dig into that, and here's where you're going to actually start looking at the code. And even if you don't really know the language that the application's written in, understanding these big O notation patterns will help you identify potential performance bottlenecks. So you'll be able to look at the code, see where they're iterating over some items, and then look at the way that they're solving that problem. What algorithm have they chosen to use? And does that scale linearly, or is it scaling logarithmically or exponentially? In an ideal world, what you want is an algorithm that runs at a constant big O runtime. So no matter what you provide it, it's always taking the same amount of time and memory. It's pretty rare for that to be a performance bottleneck. A lot of times what you'll see is something that scales linearly or exponentially with the inputs being provided to that. And so you want to rethink that, or at least point it out to the software engineers so that they can go back and figure out a more efficient way to handle that solution. So there you go. Something from the computer science world that's actually relevant and helpful in the tasks that we get assigned as DevOps people. Hope you found that helpful. And what was I going to say? Hold up, I'll be right back. Figured out what I was going to say. So I hope you found that helpful. And if you enjoyed this video, you might actually determine or discover that you like the software engineering side of things and that those kinds of problems are interesting to you. Well, it doesn't have to be an either or choice. So check out the video that I released on software engineer or DevOps engineer. I'll put a link to it here on the screen. I'll throw a link to it down below. In the video, I talk about the difference between those two roles, how they overlap, and hopefully provide enough value to you there that can help you steer your career decisions accordingly. I'll see y'all in the next video.